Good afternoon, ladies and gentlemen. I'm going to back off the microphone now. How's everyone doing? Welcome. We're very excited to be here at the AWS Public Sector Summit. My name is Pete Neuwasser, and I'm a cloud architect with Deloitte Consulting. Thank you for taking the time to join us today. Our time together this hour will be spent with Dougal Ballantyne, who is the Principal Products Manager for Serverless at AWS. We will explore the evolution of serverless at AWS and get updates on AWS Lambda and the broader serverless ecosystem. And regardless of where you are in your own personal or enterprise path to cloud, you'll just be sure to and expect to learn a lot about the benefits and some of the mission outcomes that serverless has enabled in the marketplace and what's available to you. At Deloitte, we operate at the intersection of where cloud meets our clients' missions, from cloud native and cyber to data center transformation and multi-cloud management. Our offerings focus on helping our clients understand new cloud trends and how they fit into your broader adoption strategy, things like serverless and the impact that they have on increasing agility and reducing costs. Please do feel free to come say hello. I'll be in the back after the session. And please do visit our booth where you can learn more about how Deloitte can cloud ready your mission, transform your data into mission insights, manage risks, and deliver applications at the speed of digital. And with that, I'd like to present Dougal Ballantyne.
Thank you very much. Okay, good afternoon, everyone. My name is Dougal Ballantyne. I'm, as we got introduced, a Principal Product Manager with AWS and Serverless. I've been with Amazon almost 5 years and worked on quite a few interesting things, high-performance computing, building new services. It's about at this point in the presentation, if you've ever seen any of our serverless talks in the past, that our GM, Tim Wagner, will come out and try and destroy some servers. He takes a baseball bat to them. If you're lucky, he takes a samurai sword to them. He made them disappear in Vegas. At the serverless conf, he actually decided to make a serverless smoothie with a blend tech. Unfortunately, I wasn't approved to do any of those things, so I'm just allowed to give the presentation and wait and hope one time that I'll get to come and blend something or destroy something. So for those of you who haven't already joined us on the serverless journey, I want to bring you up to speed with what Lambda is, with what serverless is, what the ecosystem of serverless is on top of AWS. And then we'll take a look at how customers are achieving faster time to market, shorter time to deploy code, more secure architectures, and more real-time business results by adopting serverless solutions. And then finally, we'll take a look at some of the specific features in both Lambda, API Gateway, and the serverless ecosystem, which we've launched over the last couple of months, and highlight some of the key features in those new services. So before I dive too deep into our presentation, real quick show of hands, how many people would consider themselves to be production on serverless today? Okay, so there's a few people in there. How many people are using Lambda, feel like they're doing something with serverless, and you know, they're on the journey they've started? Cool, that's good. Hands up, who's here to find out what the serverless thing is? Okay, cool. So we have a good mix, and hopefully we'll be able to cover all of that. As we go through, hopefully we'll tease out all these different things, the tips and tricks as we go. I have the privilege of having built actual production services on top of serverless, so I've got some battle scars from it as well. And if we have enough time at the end of the presentation, we'll try and do a little bit of Q&A. So what is serverless? What is the whole notion of serverless for you and for us? Serverless computing lets you build and run applications without thinking about servers. Your application still runs on servers. We still have servers. There is no magic there, like they don't disappear. But the management, the responsibility of the servers moves over to AWS. You no longer need to think about hardware provisioning, OS patching, uptime, dealing with maintenance cycles, hardware refresh. That all moves over to AWS, and that's the responsibility of the AWS Lambda team. And it's not just the hardware infrastructure that you get to stop worrying about. It's also the servers themselves, the software components of the servers. No more chef deployment scripts to make sure all the servers are configured at the right release, or making sure that the right version of the application is deployed at the right time. Application deployment happens at the same time as the request is being made in a serverless architecture. So let's take a little bit of a look at the evolution of how we got to serverless. Understand a little bit about where we started, the journey that we've all been on, I think, in IT as a whole, and what it looks like. The modern era of computing has gone through several phases, with each new era shaping the software and the operational procedures before it and then going forward. We started out with physical data centers, servers racked in your own environment, constraints there being the number of servers you had and the size of your environment. And then we made a move into virtualization, so the ability for you to start to virtualize your servers, so you started to get amazing economy out of the utilization, but you were still bound physically by the constraints of your data center. You could only go as big as the rooms assigned or as much cooling and power as you had available before you had to start building more of that physical infrastructure. So the cloud took your virtual servers and moved all of that physical management, the HVAC and the building, and turned it into a provisioning operation. Create servers, and with an API response, you got virtual machines in the cloud. At each stage of evolution provided a key improvement. Virtualization improved utilization and increased uptime for applications and made it more resilient to hardware and software failures within your architecture. The move to cloud capitalized on this trend, turning the lengthy and expensive data center projects into API calls. It also began the important process of shifting the burden of maintenance from application owners to cloud service providers. But even with cloud infrastructure, it has limitations. You still need to administer the virtual servers. We didn't remove the need to ensure that all of your machines were configured consistently. This capacity, and then in addition to that, we also left you with the challenge of managing capacity. You still need to make sure that you have the right amount of capacity available for your applications. If you have too much capacity, it's over-provisioned and underutilized. If you have too little capacity, then you might end up giving an impact to your applications that are running on top of that infrastructure. Now, we give you tooling on top of the AWS cloud to do this, but it was still on you to go ahead and manage that and control how that was going to be implemented. And that's a challenge, and it's hard managing fleets of servers. So AWS asked ourselves a question, or we as a team, we asked ourselves a question, and the question was, so how can we meet future needs by further reducing friction in the IT management process that keeps us from rapidly introducing and scaling new applications? And our answer to that is AWS Lambda, the serverless compute solution. It offers all of the benefits and compute power of existing cloud infrastructure without the operational complexities of running your own fleet of servers and managing those fleet of servers within your environment. Both the hardware and the software models get simpler and easier. All of the responsibilities we previously discussed, they go away. No more provisioning and utilization to worry about. No more availability and fault tolerance. No more scaling, no more operations and management. With Lambda, these challenges all move over to AWS. You can focus on your business logic rather than where and how it runs. Security patching, like, for example, dealing with dirty cow exploit. Hardware migrations, moving from one generation of hardware to another. Machine maintenance cycling that needs to be carried out. All AWS's responsibility. And it doesn't cost Lambda developers any time or effort. They don't need to think about that. It's not something they worry about in their architecture. Now, serverless is a form of event computing, or event-driven computing. And event-driven computing is a large space and fundamentally probably one of the most powerful ways to think about building application architectures, because all of the compute is driven by specific events. Function as a service is one of the ways that you can solve event-driven computing. And you can today deploy your own architectures that provide function as a service. But we fundamentally believe that serverless is where you actually deliver the entire thing without the customer thinking about how to deploy and manage that function as a service, how much infrastructure is required to build it and operate it, and how to maintain it once it's up and deployed. And that's where we think Lambda sits. We think Lambda is the answer to true serverless computing. So we said it's already event-driven, And with the event-driven model, it's very, very easy for you to construct an application that will continuously scale based on the amount of events that are passing through it. Continuous scaling is a core promise of AWS Lambda. It scales based on request, not based on CPU utilization or number of users. It's literally request per request driven scaling. It's also truly pay per usage. When your code is not running, there is no cost. We bill by the 100 millisecond for a Lambda function's execution. So when someone's executing a Lambda function, it's getting metered. When that Lambda function's not being executed because there's no events in your event-driven model, there's no cost to having your application deployed. But on its own, Lambda is just the compute component of an entire serverless ecosystem on top of AWS. We think of serverless as many, many components. And I'm going to spend a little bit of time later on in the presentation talking about some of the key features and how to use those features. But I want to call out how we think about it a little bit. So when you look at something like, say, Amazon S3, it's serverless storage. You don't have to think about, is there enough capacity to store my data? Is my data going to be available? Who deals with making sure the servers are up and running in my storage solution? DynamoDB, NoSQL storage, or NoSQL database. Serverless. You don't need to think about deploying the DynamoDB infrastructure when you get started. Kinesis, analytics in a serverless fashion. You can even join, for example, API gateway to Kinesis and do real-time streaming ingest over simple HTTP endpoints. Amazon API gateway, the ability to put a RESTful interface in front of many AWS services, including Lambda and your other services. No servers to deploy or scale. Step functions. And we'll talk a little bit around some of the step functions functionality. The ability to orchestrate things with state machines. In a fundamentally stateless architecture, which Lambda is, the ability to orchestrate functions is extremely powerful. The ability to use decision logic as to whether you want to invoke one function after another function, synchronize and barrier operations, it's an amazing amount of control. We'll talk about X-ray a little bit as we go further on. The ability to deep dive into precision trace points inside your application. And then we'll go a little bit further into some of the edge compute. It's actually something I think is really cool. The ability to run Lambda all the way out on the edge and even on devices that aren't in the cloud. So serverless changes how we deliver applications, and it also changes how customers start delivering their applications. All of these services have a common goal, speeding up the innovation and delivery flywheel. By removing the friction of thinking about compute, storage, and networking, it makes it easier for application developers to do quick deployments immediately to a large fleet driven by Lambda and immediately expose that application code to a new set of customers. There's no need to deploy code across multiple AZs. Lambda takes care of that. There's no need to deploy capacity management or fleet policies as we scale out your application. All of that's taken care of by Lambda. And all of these capabilities, when combined together, drive the flywheel of innovation for you as a customer. It's possible for you to move faster and more agile using a serverless architecture. So I want to talk a little bit about serverless today. Where are serverless customers today? What are the use cases that we're seeing with our serverless customers? What are some of the patterns that serverless customers and partners are using to build on top of AWS and you can take advantage of? So common use cases. Now, the one thing that is quite evident when you start talking about common use cases with serverless is there's a lot of them. There's no one use case. There's no one thing that Lambda is designed specifically to do. It's able to do many, many different things, and this is possible with the serverless ecosystem of connectors and triggers and integrations. So if we start with web applications, for example, you can start by hosting a completely static website on S3, and when anyone hits that, you get the power and durability of S3 serving that, and you don't need to do any servers anywhere. You just deploy your static content up to S3, and everyone can access it. But then you can start adding dynamic content into your website. You can take an API gateway to put a RESTful interface or HTTP interface in front of a Lambda function, and now do interactive content within your web pages, dynamic web page generation, using a Lambda function and no servers. And when you have a flash sale or your site is the hottest site on Reddit that day, it scales seamlessly with no concern at all for the volume of traffic that's being sent to it because it's serverless. When we take a look at backends are really fascinating. Customers are building more and more advanced backends on AWS Lambda because they can easily access all of the serverless backend components for persistence and state. The ability to store and read data from S3 and Dynamo, the ability to use step functions to make decision logic as they go through the backend. With mobile, it's possible to build really rich mobile applications that are serverless, using things like Cognito to manage mobile data and the mobile identity, and then deploying all of that out through things like CloudFront so it's easily accessible to mobile devices, and any of the logic inside the application being powered by a Lambda function. IoT devices, so devices all the way out on the edge, devices that are far, far away from the cloud, maybe operating in the back of a refrigerator or in an agricultural machine. The ability for those devices to make calls back up into the cloud, where they maybe have to unload sensor data or they want to get an update of status of data they need to operate. By moving that into a serverless architecture, you don't need to worry about scaling that backend anymore for the number of devices. As the number of devices grows, your backend automatically grows. If the frequency that the devices call in changes and you suddenly have spikes, that automatically grows. Big data use cases. Now, this is one of the first use cases we had for AWS Lambda. With big data, we see many, many customers moving large volumes of data up into, for example, S3 or pulling it into Kinesis for stream analysis. And using AWS Lambda, you can build an entire serverless data analytics platform that works using triggers. So when you upload data into S3, it triggers a function in Lambda, and that Lambda function can then do analysis on that object or that piece of data you placed in S3 and immediately publish the result. That can move data analytics from hours or even days down to minutes and less. The data is being analyzed in near real time by functions that operate on discrete portions of your data as it's being uploaded. Media and log processing. So the ability to do log processing in the cloud has been around for quite some time, people building big Hadoop clusters doing analysis. By having your log files pushed to S3 in a similar big data platform, you can have immediate log file analysis publishing out. Those log files can be going to Kinesis, so you can be ingesting them in real time and having a Lambda function cut into the stream and do analysis as they go through. And chatbots, things like Amazon Echo and Amazon Lex, Lambda has native integrations into those, so it's now possible to build really powerful and rich chatbots that are serverless, no infrastructure behind them for you to manage and scale, and deliver a really rich interactive experience for your customers who are interacting over those mediums. Or Alexa skills, and the more Alexa devices talking to it, you don't need to scale, it automatically scales. So let me take a little bit of a look at the MapReduce model. I think it's a really interesting one because a lot of people associate a MapReduce framework with a large collection of commodity servers with a big HDFS file system. It's kind of like a big HPC approach to big data. And we've seen a lot of customers now moving towards a serverless MapReduce implementation on top of AWS Lambda. And the way they do this is your inputs are basically puts on S3. You then have a map phase in the function, so it's a dedicated function for the map phase. After that, it then usually goes through a coordinator, which is not in here, and then onto a reduce phase, and then a final reduce phase followed by a publication of results. And this can happen real time on data sets. And in fact, we actually thought it was so good of a reference architecture that we took our time and we've actually published a reference architecture on AWS Labs GitHub that deploys this and enables you to build this architecture. And so if we start up on the top left-hand side, we have the data, something coming from the driver, number one, and it's pushing data into the input bucket. And as data is put in that input bucket, it actually triggers a mapper function, number two. And then it goes to the mapper output, and the mapper output's going back into S3, maybe a different prefix inside your bucket. And then it has a coordinator, and the coordinator is outputting job state as well and letting you know how it's moving along. And then it moves into the mapper phase, the reducer phase, where it's reducing down the results from the earlier stage. And we have a final reducer that will push the result out. And those results are being pushed in real time. As the data is being ingested, it's actually real-time map producing on top of that data set. And we've analyzed a couple of big data set benchmarks. And we did 126.8 gigabytes of data across 775 million rows. And when we analyzed these queries against others like Redshift, Impala, Shark, Hive, they were all faster, except Redshift. But we know who's building Redshift and the team who's working on that. So it's an extremely powerful, scalable system that enables you to do serverless big data processing. Another framework that recently came out and is getting a lot of attention is something called PyWren. So PyWren is a completely open source MapReduce framework for Lambda. And they've published some really phenomenal benchmarks. And I think the thing that's really interesting is when they're doing these benchmarks, they're publishing them in numbers and in sort of benchmark classifications that you'd used to see from really, really big systems. And these are systems that are costing pennies to run through. And so they are actually able to achieve in some of their data sets 60 gigabytes a second read and 50 gigabytes a second from S3 in write. Those are huge volumes of I/O in and out of S3 in a serverless architecture. And the academics agree as well. I actually think this is, for me, I actually think this is really interesting. So my background is high-performance computing. I spent a long time dealing with wrangling big HPC clusters and managing who was allowed to have access and priorities and scheduling and all the stuff that goes with this. And they call this out in this paper at the University of California, that most people don't ever get access to distributed computing at scale. It's a really, really restricted set of people who get access to really big computers and can run things at scale. And that's really a shame, to be honest. Like, there's an awful lot of really cool work could be done if you were just given a bit of time on it. And if you're lucky, maybe you get some background time on the nighttime queue or something like that. But that's not the same as actually getting access to go work on this. And so they've done a phenomenal paper. They reference PyWren in here. I recommend looking it up, about how you can actually get access to just phenomenal amounts of distributed compute power in an easy-to-use framework that really unlocks distributed computing for a much larger audience of people. So a couple of things have changed in Lambda in the last period. And I want to highlight some of these changes. So we started out with 100 concurrent functions. That was our initial one. We've gone to 200 concurrent functions. We went to 400 concurrent functions. Oh, we're actually at 1,000, sorry. We're at 1,000 concurrent functions now. And so 1,000 concurrent functions per second is our default limit in Lambda. And the reason I wanted to highlight this is, for some people, if you're doing 100 millisecond functions, that's 10,000 invokes per second. That's the default limit for any customer starting with AWS Lambda today. And so it's a huge amount of power at your fingertips that you can immediately start to use for building large, complex applications. So there's a lot of customers building on serverless. Lambda has been out for a little over 2 years now. The growth and the pace of adoption of serverless is absolutely breathtaking. From successful startups like AdRoll and Logalytics to Fortune 500 companies like Coca-Cola and global enterprises like Thomson Reuters. Companies of all sizes, all shapes, all workloads are moving over and starting to leverage the benefits of a serverless architecture. I just want to take a moment and call out a couple of them specifically. So Thomson Reuters has a real-time analytics engine that processes data at a rate of 4,000 requests per second, and it's all serverless now. They have real-time analytics of data coming in from all of their different feeds going directly into a serverless architecture. FINRA is a customer we've spoke about many times at AWS. I've been with AWS long enough to see how FINRA started their journey. They used to run very large Hadoop clusters. They do analysis of all of the trades within the US markets, and they analyze those trades for bad behaviors or unexpected behaviors in the stock market. These were massive, massive Hadoop clusters, and it took hours to get answers. And they've now been able to move that over into a completely serverless architecture, and they're now able to get answers in minutes. They can detect fraudulent activities or unexpected behaviors in the stock market in minutes through a serverless architecture. And the volumes in the stock markets now literally follow the volume of serverless activity they have. There's no over-provisioning or under-provisioning of the architecture or backlogs of data building up while they're going through this. Hearst has reduced the time to ingest and process data for its analytics pipeline by 97%. They used to do this previously in 4 hours in their old batch system. So this has been huge for them to come down to minutes. Vivo, it's a content platform for artists and musicians. They've now been able to handle 80x their normal traffic in spikes. So this is when an artist publishes new content, and it's a hot new artist, it's in the Billboard top something, and everybody rushes to find out all about the artist, the details around what they've just released. Previously, they had to build an architecture that was ready for that, but how would they know when to be ready? How do they know when the artist is going to break? How do they know this artist is the artist that will get the most airtime that week? And so this enables them now to no longer have to try and hope that they'll get it right in scaling. Serverless scales automatically for them. And Expedia uses an awful lot of serverless. So Expedia has multiple serverless use cases, including an automated CI/CD platform that has 3 million code deployments per month at a cost of less than $1 using serverless. As well as their DevOps automation platform, which is generation of traveler profiles, and it performs more than 1.2 billion requests each month. So I think it's really interesting to see these workloads, and it highlights just the diversity of the workloads that people are able to build and construct on top of the serverless platform. So serverless is really becoming the core of a modern app ecosystem. On top of this, there's lots and lots of components around these modern applications. And we're going to spend a little bit of time understanding how these tools and components come together to enable you to build serverless applications. Oh, sorry. So we talked a little bit about the history of the service, AWS Lambda, and we've talked a little bit around how the customers are using the platform. And now what I want to do is probably pivot a little bit more into the technical component of the session today, talk about the actual components within serverless. I also want to highlight some of the core features that we've launched in the platform, and hopefully this will give you food for thought for questions as we come up to the end of our session today. So a serverless platform has, in our opinion, a core set of capabilities. A cloud logic layer, so this is the ability to execute logic decisions, orchestration and state management, responsiveness to data sources, so a rich, broad set of data sources that can be interfaced or trigger events inside of a serverless platform, the ability to define your applications in a framework, an ecosystem, so there needs to be a vibrant ecosystem, both of tooling that's provided as part of the serverless platform and people building tooling around that. A set of integration libraries to make it easier for you to build serverless applications. Security and access controls, reliability and performance, and global scale. Those bottom three are really key across the whole AWS platform. So the cloud logic layer. Computing is the keystone of the serverless platform, and Lambda is the central hub that receives events, processes them, and makes calls to the other AWS services and third-party services. If Lambda is the implementation, then API Gateway is the interface, offering fully managed APIs with fine-grained access control and usage controls. And I want to take a quick look at some of the new features we've added in those recently. So we added a new Lambda runtime. We added Node.js 6.10 that was earlier this year. And we also recently announced Python 3.6. Now, Python 3.6 has received an awful lot of positive feedback. I personally am a Python developer, and Python 2.7 was great, but Python 3.6 is a really mature library, or a really mature language with a strong set of standard libraries. And so being able to develop things in Python 3.6 natively on top of Lambda is a huge change for us. When we talk about the ability to observe and control access in your Lambda functions, tagging is the key thing that customers ask for. So we recently launched tagging for Lambda. Now it gives you the ability to add metadata to your Lambda functions using tags, for example, project, team, department, cost center. And because you can do things like tag it with cost center, and our tagging is integrated into our billing, it's now possible to do detailed cost-based analysis of Lambda usage within your account. So if you're tagging your Lambda functions to teams who are using them or projects who created them, it's now possible in detailed billing to see the cost of those functions and how they're being used. And this is actually a really big change for our customers. It was a lot of log diving in the past, so we're very excited to be able to make that available. And a couple of other recent changes around the cloud logic layer. So iterator age for Amazon Kinesis records and DynamoDB streams. So if you've taken a DynamoDB stream, which is basically a streaming record of all changes to a DynamoDB table, you can connect that or integrate it with a Lambda function so that the Lambda function processes that stream and makes logic decisions or does logic in the cloud on top of those. Now, it's all asynchronous, so these are what we call our event-based model inside of Lambda. And in the past, it was hard to tell how old records were, how old that queue of asynchronous events were. So this now gives you the ability to see how long it's taking for events to process through your async pipeline. And the other thing we've added is the ability to view function policies from the console. So if for the people who are really deep in Lambda, the people who said that they were doing production workloads, there's two ways of sort of securing and controlling access to a Lambda function. You can do it through a IAM policy and define what person has access to it, but you can also do what's called a resource policy. And a resource policy is a policy that's associated with the Lambda resource itself. And in a Lambda function policy, you can say, for example, I want to allow S3 to call this, or I want to allow API gateway. And it's a much more fine-grained way of controlling access at the function level. Previously, you had to use the AWS CLI to view this policy. And so we recently added the ability to see these policies in the console, make it much easier for people who are developing and debugging these. We've also achieved HIPAA compliance for Amazon API Gateway. There's another thing I don't think I've maybe gotten here we should call out for the GovCloud customers. We launched Lambda in GovCloud just last week, and so that's a really big deal. Yeah, thank you. One GovCloud customer. We also added a little bit more to API Gateway. As someone who's built a service on top of this, this is something that I actually get really excited about. So when I think about serverless and what it's done for me in the world of servers is I no longer need to worry about servers. I don't have to worry about the provisioning and management of them. When I'm building a set of APIs or I'm building a service that exposes itself as APIs, request validation is an important but often annoying amount of work I have to do with inside my code. I have to validate that if I was expecting a string, I got a string, so I don't throw an exception in my code. And if I do, I need to catch it and throw it appropriately so the person who was calling my API gets a nice friendly message that says, unfortunately, I was looking for a string and you sent me something that wasn't a string. And that's boilerplate code to anyone who builds applications at scale, but it gets very big very quickly. So every single field should have input validation. You should validate that you're catching and checking all of those as you go through. And so what we've done with API request validation is in your request model for API Gateway, you're already telling API Gateway what to expect. You're saying that name should be a string and that house number should be an integer or a number. And so you've already defined that in there. And so when you turn on request validation, API Gateway will actually do the work of validating that the request complies with the request format or the request map that you've defined, and then reject the request with a 400 error, which typically means client error, saying request doesn't meet validation. Now, for the person writing the code in the Lambda function, I don't actually need to do any more request validation. I can assume that the payload I receive within bounds is valid. I don't need to check anymore the contents. So now I'm right back to where I want to be, which is only writing business logic inside my function. I don't need to deal with boilerplate anymore. Keeps my function code base smaller, and enables me as a developer to focus on the things that are important as I go through. We've also added ACM integration, so AWS Certificate Manager. AWS Certificate Manager is a free and super awesome way to add SSL or TLS certificates to AWS resources. And with the integration with API Gateway, it's now easy to use certificates you've generated there, my API or api.mycompany.com, and have that associated automatically with the custom domain. And then ACM takes care of certificate renewal and rotation. You don't ever have to worry about getting that trouble ticket from a customer that says, I tried to hit your SSL and it told me your certificate's expired. It's a huge trust breaker if you ever hit that one. So that's a really exciting feature. I talked about responsive data sources, so a broad and deep ecosystem of data sources that you can use in a serverless world, and how that's important to make serverless successful. So Lambda supports a very broad set of event sources. And these sources are things like triggers on put of an S3 object. But we've gone even further than that, and we've expanded that to include a large set of different triggers. So for example, we now support Kinesis Firehose, one of the fast ways of getting data in. You can attach a Lambda function to that. You can now trigger things from an Amazon Aurora database as a Lambda function. And for folks who spend a lot of time dealing with stored procedures, wow, we just made stored procedures entirely function-based inside of the cloud, which is really cool. We talk about Snowball Edge. I'm going to talk about that probably a little bit more in the slides further on, but for the folks who don't know, Snowball Edge is the ability for you to have a storage and compute device that you take on-prem, and you can even run Lambda functions in there. So as data is being loaded onto the Snowball device, it will actually pass through or be triggered against a Lambda function. So you can do data validation and say, the data I'm uploading at the edge in this device I shipped out to my remote location has to be compliant with this standard I want. I want all the records to be uniform length. And so you can actually have a Lambda function on a Snowball Edge device that does that. AWS config, AWS CloudFormation, AWS commit. This is where Lambda really becomes the Swiss Army knife on top of your services. So you can take AWS config, and when there's a rule change inside AWS config, so AWS config keeps track of all of the resources within your account and the state of them, and as the state changes, it generates events in AWS config events. You can have a Lambda function that takes a look at that event and takes corrective action. Now, the classic example that a lot of companies are adopting now is no tag, no run. So you launch an instance or a database, and it comes up and it doesn't have a tag that says cost center or project or team. There's an AWS config event for that. There's a Lambda function that says no tags, and it says stop or terminate. And there's no email, there's no nicety, it's just real simple. No tag, no run. And it's very, very easy to do with this, and you can control exactly how you want that to happen. With CloudFormation, you can basically build any custom resource you want with a Lambda function. So you can even use CloudFormation to orchestrate components in your own data center. You may have resources that you want to turn on or register with when you create a CloudFormation stack. By creating a custom resource with AWS Lambda, you can actually have that Lambda call, make a call back into your data center. Maybe you need to update your config management database that's still hosted on-prem. You can make that call. It will call back in, and it's part of your CloudFormation stack. It's extremely powerful. And then we have things like Lex and others, folks like Twilio, who've added things like Twilio functions that give you the ability to do serverless interactions over different text messaging channels, or Lex with the ability to do a chatbot directly. Then we have integration libraries. When we think about integration libraries, it's the ability for you to get access to more APIs that aren't already integrated into your system. And so Amazon API Gateway listings are now available in Marketplace. So what that enables you to do if you're a service provider or you're providing services to customers who you want to charge for is the ability to provision a serverless application through API Gateway and have customers consume that and build onto their everyday normal AWS account without having to go any further than just clicking, I want to use this service. It's an extremely powerful integration, I think, and we're seeing a lot of interesting uses. Two of the interesting ones I wanted to highlight was NTT Docomo. So NTT Docomo has actually got an image mutation library, or an image recognition library, and then F-Secure is for URL, what's the right way to describe it? Content validation of URLs to make sure the reputation of the URL is at a certain level. So, is this URL an appropriate URL to go to for my organization, things like that. And these are available today in the AWS Marketplace as APIs that you can just make calls to from your serverless application and consume, or you could publish your own in there as well. So reliability and performance. Reliability and performance is something that's ultimately our responsibility for a large part. We've taken on the responsibility to make sure that the Lambda platform is up and running and it's delivering your functions at the concurrency that you expect. But sometimes your code doesn't go well. Sometimes your function is maybe what's not effectively working, or sometimes the data you're putting into that function isn't expected. And so one of the features we launched about almost a year ago, but it's a feature I want to highlight today specifically, is dead letter queues. Now with dead letter queues, it enables you to redirect failed events to an SNS or an SQS topic for further processing. Now, as I mentioned earlier, my background's in HPC, and I've built a lot of batch systems, including actual batch services. And when you understand what this architecture gives you, I think it's probably one of the most powerful things we've done for high volume processing. So in your normal pipeline, you have a single function, and the only code that's in there is the happy path. It's a really, really small piece of code. Its job is just to do the one thing that it's supposed to do in the pipeline. Maybe it's a data transform, maybe you're analyzing records to look for a particular piece of data, but that's the only thing you do in there. There's no conditionals, there's no fault handling, there's no error checking. You just do one thing and one thing really well. 99.9% of your traffic is going to use that happy path function, the one that's super, super lean that you don't ever have to worry about. And then you have a dead letter queue for things that fail. And the dead letter queue is also connected to a Lambda function. And that dead letter queue has got a really rich, heavy function, really verbose. It echoes the contents of the event as it's coming in. It does a whole bunch of error handling and checking. Maybe it tries to validate the data using a different set of parameters. And you can make changes to this function all day long, and you're not changing your happy path code. You're not touching the piece of code that processes 99.9% of your work. And this separates the two out so that when you're doing deployments to this piece of code that's important to deal with failure, you're not ever touching the piece of code that deals with happy path. So as more and more customers are moving from monolithic applications and adopting things like Lambda functions to build out microservices, you end up with lots and lots of components. So what happens when you have an entire application made up of all of these little functions, Dynamo tables, API endpoints? How do you manage that? How do you bring all of that together in a way that it's something you can manage as an application or a deployment unit? And so this is where we meet Sam. Sam is our squirrel, or as we refer to him, the serverless application model. Sam will appear more and more as you go around our A, the presentation today, and B, as you go around the serverless website on AWS. And Sam is a way for you to identify part of our framework and tooling that we're using to build serverless applications. So it's a standard model for representing serverless applications on AWS. It brings together all the parts of a microservice in a standard way that you can describe or model it. With SAM, you can now have a simple language for talking about the pieces of your application, the function, the API, the event, the data stores, and more. And with this model, you can now inform all of the steps in an application's lifecycle: building, packaging, deployment, and maintenance. So what it does is it controls how your application is defined. It's natively supported by AWS CloudFormation, so you can think of it as a superset of AWS CloudFormation. You can export any function as a SAM template. You can package and deploy SAM templates easily using the CLI. And a really important thing, I think, is we've released this as an open specification under the Apache 2.0 license. So this enables anyone to use the SAM specification to build serverless applications and incorporate them in their workloads. We added a couple of new features recently for people who've already started using it. Support for inline Swagger, so you can now inline a Swagger document inside of your SAM template. And intrinsic functions, or intrinsic functions, the ability to use things like ref and fn get attributes inside. Now, CI/CD is, inside Amazon, like critical. That's how we build and deploy our services. And more customers have adopted CI/CD for their application deployments. And as they move to serverless, they often come with the question, well, how do we do CI/CD in the serverless world? How do we ensure that we stay with all the benefits we got from that? And now that we've introduced SAM, there's a way for you to define an application. And once you've used your SAM definition, you can commit that to GitHub or Amazon S3 or code commit. And then using code pipeline, you can move that into code build. And code build will actually build your Lambda function artifact. And for people who've been building a lot of Lambda functions for a while now, you can also pip an NPM inside code build. So you don't need to push up the dependencies of your Lambda function anymore when you do your commit. You can just push the code. And then you can move it through a test environment and validate the functions using code build again. And because it's CloudFormation, you can go out and do a deployment to multiple stages, test, dev, and have a whole pipeline to accelerate yourself through that. And that's great. We now have CI/CD. We have applications defined as SAM. But how do we debug this? Like, how do we truly discover when things go wrong, where the problems lie? And so this is where Amazon or AWS X-Ray comes in. So X-Ray enables you to do tracing and debugging of applications, and it's supported across the serverless ecosystem. And so it will enable you to pinpoint precise, specific issues and identify where that issue is and what happens. I'm looking at my time here. I'm a little bit tight, so we'll go a little bit quicker. So we'll talk about how to use X-Ray, because I think it's important to highlight the example. So this is a very, very simple Lambda function, okay? And I'm just doing a put item in a bucket. And I'm going to execute this and take a look at what's called the service map within X-Ray. So you can see in the service map here, the client made a call to Lambda, Lambda invoked a function, and inside the function, we made a call to S3. But that call to S3 got a 4XX because of the orange highlighted in there. If I go dive down into the actual trace for this, and you can see, for example, the trace has the request ID and all of the timing and the bars for this, and I click on it, it says, the specific bucket does not exist. That's the actual error that occurred inside that function. And if we take a quick look at the code here, you can see there's a misspelling on bucket. And so clearly this is what happened. Now, it's a very, very simple example. A misspelling in a bucket is something you might have caught anyway in your earlier testing. But when you have a serverless application at scale with many different data sources you're ingesting, the ability to do a trace-level analysis and identify exactly where that problem occurred and with what component and service is a really powerful feature. Easy enough to fix, and if we run it again, we see it goes green all of the way. So I want to talk a little bit about the developer ecosystem. And this is the commercial developer ecosystem. So we've got companies like Twilio who enhance their core capabilities of Lambda by integrating it with their messaging APIs. Zapper, who's making it easier to connect applications and automate workflows for enterprise event systems. Datadog and Loggly and Splunk are building serverless applications to enable developers to do more enhanced and advanced auditing of their application behaviors. And there's even more companies like this inside the Amazon Partner Network. It's really, really amazing to see how fast the serverless ecosystem is growing. But then we also have an open source developer ecosystem. So the open source developer ecosystem, you can see SAM there, but we also have things like the Express framework and Chalice framework that we've published, Python and Node.js, the serverless.com framework. And all of these frameworks are making it easier for developers to build serverless applications without having to start out building the scaffolding. And it's amazing to see that growth in this space. Quick update on AWS step functions. For folks who don't know, step functions enable you to do state management across different Lambda functions. We added a few new integrations recently. So an integration with API Gateway, meaning when someone calls an API, it directly triggers a step function. So you don't need to call a Lambda function to call a step function. It goes directly to a step function. You can now do error handling for Lambda functions, so it actually truly understands the error codes. And you can send CloudWatch events directly to a step function. So if you've got a CloudWatch event for dealing with AWS config, it can go to a step function that can have logic decisions in there before executing. Now, I talked a little bit at the beginning about how exciting it is to see Lambda everywhere, Lambda leaving the confines of the region. And so AWS Greengrass is something that went GA just last week, or actually, just last week it went GA. So AWS Greengrass enables you to deploy Lambda functions to IoT devices. It actually enables you to take a Lambda development environment, a Lambda programming environment, and deploy it down onto a device that could be, as we said, in a refrigerator or on an agricultural device. So now you have the ability to execute the same code path that you're executing up in the cloud, but right beside where the data is being ingested or where the sensors are being triggered. So really, really exciting thing to see Lambda in places that really aren't even connected to the cloud in some places. Snowball Edge, I touched about this earlier on. It's the ability to deploy code out onto a Snowball device and have Lambda actually execute code while your data is being loaded onto the Snowball device. And then AWS today has many different regions, and Lambda is available in almost all of our regions, 13 regions today, and we're working really hard to be in every region all over the globe. And that's really amazing, and we're really excited about the number of regions we're in. I think we just recently launched in Sao Paulo, and GovCloud was last week. But going further than that is the ability to put Lambda all the way out to the edge. We're the closest point of AWS to your customers. So this is something called Lambda at the Edge, and it's still in preview today, but it enables customers to actually have Node.js functions that operate inside of a CloudFront POP. So the idea here is that when someone makes a request to a CloudFront POP, you can trigger a piece of Node.js code to handle the request and response behavior right at the edge. You don't need to bring it all the way back to your origin that might be running in the data center or running up in the region. It happens right at the edge, closest to the customer. And so you can handle origin requests, origin responses, and also viewer responses. And the patterns in here are really quite extensive. And over time, we're going to continue to expand these capabilities to a point where you're truly going to be able to render dynamic content on the edge without going back to an origin, all through a Lambda function. The other one that's really interesting in here is, so I just did content customization, visitor validation, being able to check people are who they say they are right at the edge and never sending that back. It's very easy to do. And A/B testing is really amazing. So with A/B testing, you can make decisions at the edge as to which origin you want to send that request to. And these Lambda functions, they deploy in the same way you normally deploy Lambda functions, so you can make updates to these real time. So serverless has now become a fundamental component of modern applications. A couple of years ago, our GM, Tim, was up on stage at reInvent announcing this crazy new idea that we'd have functions as compute or compute as functions, and that the only thing you'd pay for was the time that it executed, and all you had to do was send us a little bit of script or a little bit of code, and we'd take care of all of the rest. And if we look at where we are today, it is a huge, massive growth in this space. But as we like to say in AWS, it's still only day one for us in serverless. We have an awful lot more to go. We're really excited to see what customers like yourselves are able to do with the platform. And that's all, folks. Thank you very much for coming to the serverless talk.